So typically when we're talking about current through a wire, again, we just think of the wire as one-dimensional, and so therefore all the charge is passing by a point in the wire. But as I said earlier, it's actually passing through an area. So we really have to define, in order to talk correctly about how current passes through a wire, we have to talk about current density, which is J, and it's got a direction, right? Because when I say cross-sectional area, think of a wire as a cylinder, and so the cross-sectional area, right, of any point in the wire, the current is passing through that. But the current could, although in a regular wire it doesn't seem like there would be any reason for it to, the current could pass through at some angle. So if it's a one-dimensional wire, the current can only go in one direction. I'm differentiating here, wire current. And so we don't have to think about I as being a direction except for left or right. But J, current density, actually has a direction. So current density is areal density, so it's current per unit area. So the magnitude of current density is the perpendicular current divided by the cross-sectional area. So the perpendicular component divided by the cross-sectional area. Or the current density is defined in terms of its own integral. Is defined, or I is defined in terms of current density, as shown. J, the integral of J dot dA, is current. Now this integral, this is an integral because the current density can vary across an area. So this picture shows not exactly a situation that you would find every day, where the current varies across that area. So the current density varies across the area. And in a wire, you're not going to get that. But in bulk pieces of metal, you can definitely get current density varying across different areas of a piece of metal. And you can have current flowing through any kind of conductor. So for a wire, we don't usually deal with this too much. But the idea is that the current can vary across that area. Hence, we have to talk about the current density, and the total current passing through the little red area A is going to be whatever the current density is integrated across that area. So if the current density changes, it's right. So it's the current density through a little bit of area added together for the whole area. That's what the integral means, right? The current density through a little bit of area added up for the whole area, when it may vary. For a wire, typically the current density is constant across that area, and it's typically perpendicular to that area. The current in a wire is typically constant across a cross-sectional area. Across a cross-sectional area, it's constant, and the current is typically perpendicular to the area. So in that case, you're just going to get a simplification of this integral of J times A equals I. Hence, we get the equation that we showed earlier, J equals I over A. The perpendicular component, but if it's already perpendicular, then it's just the whole current. So the current density times the area is the current. So let's say that we had a total current flowing through a wire of 3 amps. So you got 3 amps flowing through every cross-sectional area A. And let's say that the wire has a cross-sectional area of 10 to the minus 6 square meters. That would be a square wire that has a millimeter on either side. That seems reasonable. It's not a square wire, but regardless, that's the equivalent. And so what is the current density through this wire? So the current density is the perpendicular component of the current through the area divided by the area, as long as the current is constant across the area, which again, for a wire, it typically is. We can make up situations where it's not. So we can, and the perpendicular component, the area is perpendicular to the area, so just I over A. So we plug in the numbers and we get J, the current density, is 3 times 10 to the 6 amps per square meter. Now you might think, wait, that's a big number. Yes, it's a big number. If the wire was scaled up to have a square meter of cross-sectional area, then there would be 3 million amps through it, right? That's a big wire, square meter of cross-sectional area. This isn't it, right? Because it is a vector, so J is, it's got a direction. And if we call the right the X direction, then it's in the X hat direction, right? So it does have a direction associated with it. Any questions? Okay, so what's Irish and stays out all night? Patio furniture. It was St. Patrick's Day last weekend, so jokes